Hi, and welcome to CyberInks. I'm your host, Rose, and today we're going to look at the OSI model, particularly the physical layer. And we will explore what the OSI model is, and we will explore what type of physical devices you will see in a company's network, and also the cyber attacks you might see and how to defend against them. So let's grab a coffee and go. The OSI model stands for Open System Interconnection. It was developed by the International Organization for Standardization in the late 1970s. It was created for a standard framework for computer networking and communication. As you can see here, it defines 7 distinct layers, each labeled with a name and a number. In this course, we are going to go through in detail each layer, exploring the technical jargon you might hear in the working environment, as well as looking firsthand how each layer works and how it connects. Within this lesson, we are going to start using labs, as I believe the best way to learn is to practice. So please download the Cisco Packet Tracer before continuing with this lesson. You can download the application in the link in the description of this video. Packet Tracer is an interactive training playground which is free from Cisco, so you can learn and play with the network devices without having to pay for the expensive hardware. So pause the video, and once you have it downloaded, we will continue. So let's talk about layer 1, the physical layer. As described in the first lesson of this course, the network is made up from these main devices. First, the endpoints. So this can be a PC, a laptop, a server. It's any device which needs to connect to the network. And this also includes access points, which are used for Wi-Fi access. To have access to the rest of the local area network or the internet, these endpoint devices are physically connected to the next important device within your company, and that is the switch. The physical device and the ports of the switch is under layer 1 of the OSI model. However, the capabilities of the device is under layer 2, which we'll cover further on in this course. The next physical device you will see in a network is a router. Again, the same situation. The physical shell of the device is at layer 1. However, the capabilities of the device is at layer 3. This is all going to become clearer as you continue through the course. However, for now, just think of the physical layer as something you can touch and move. Now, to physically connect something to something else, we need a cable. This cable, often called an Ethernet cable, looks a lot like this. You have probably seen and even held one before. It is just copper wires covered in plastic and then covered by an insulator. So how did this cable give any information to the other device? The best way to think about it is with 2 cups connected to a string. I have told the other person on the other side of the string beforehand that a hard tap on the cup means 1 and a small tap on the cup means 0. I've also told them how to decode it. So if I do 1 0 1 0, which is large tap, large tap, little tap, then this means they need to make me a cup of tea. However, if I do 1 1 1, which is 3 large taps, this means they need to get me a biscuit. And as simple as this sounds, computers work in the exact same way. The PC here will send out electrical pulses. A high voltage pulse is 1 and a low voltage pulse is 0. The switch passes the data to the correct receiver on the other end and then converts these signals into data. A fiber cable does the same thing, however, instead of pulses of voltage, it uses light. No light, 0. A light, 1. This 1 and 0 system is called binary. Here, for example, is the alphabet in binary. Pause the screen here and see if you can write your name in binary. Now it's clear how cables work, it is important to know that there are two types of copper cables. One is a straight through cable, which you can see on the diagram here. This can connect to different devices, aka a PC to a switch, or a router to a switch. A crossover cable, which we see here, connects devices which are the same or similar, aka a switch to a switch, or a router to a router. The reason of this is because devices transmit data on the pins in the cable. And if you have two devices which are the same, they will try to transmit and receive data on the same pins, which would block the transmission. In modern networks, it uses an auto MDIX. This is an automatic, medium-dependent interface crossover configuration, where the computer or switch can automatically switch the transmission over if it detects a mismatch or clash in the transmission. Now we know how to connect physically the devices and how the computers understand how to talk to each other, let's have a look at some cybersecurity risks and attack which can happen at the layer 1 level. The first attack I could do if I had malintentions would be to go into the room where they have the switch and then plug or cut the cables. This would cause the device which is plugged into the switch to completely lose connection. This is called physical tampering, and it can be mitigated by having the network devices in a security room with limited personal access. The next attack which can take place is that I can plug in a device which is malicious or has evil intent. Let's have a look at how that can be done. Here is the company's network. We have a router, a switch, and endpoint devices. We've got Linda in engineering's PC, Paul in marketing's PC, Bob in engineering's PC, and Tracy in marketing's PC. I'm a hacker working inside the company. I would like to steal documents, so I'd like to get access either to the marketing network VLAN or the engineering network VLAN so I can infect someone's machine. Here is the configuration of the switch. The network architect David, who manages marketing, does not care about security and just rushes things to get the job done. As you can see here, he has a lot of ports which are unassigned and not connected, however is configured for the marketing VLAN. This means when a user or a malicious user wants to use that VLAN, they do not need to raise a ticket to the network team. They can just put the device into the Ethernet port. Also, he did not see the point of putting in security on those ports as well. Now, the other architect, John, who manages engineering, is very invested in the security of devices and how to keep the network secure. He instructs his network engineers, if a port is not being used, please remove the configuration, as we can see here on the Ethernet ports. Also, to put security configuration on the ports itself, as we can see here. Now, let's see what I, as the attacker, can do. Firstly, I have put my device into a free port. This free port has already the configuration for the marketing team, and that port is up. Not only now do I have access within the same VLAN, but I can go virtually undetected. Now I'm in the insecure VLAN. The first thing I need to know is what my new IP address is. So to do this, I can run the command ipconfig, This is going to give me details about my device, particularly the IP address, which is a new IP address that I have, and also the range of IP addresses that are within the whole network of the VLAN. This will be described later in further lessons. Now I know the IP address and the range set, what I'm able to do is now find other devices and see if they're up or down in the network. So to do this, I can use a protocol called ping. Ping enables you to send packets to know if a device is up or if a device is down. So let's test it out. Let's ping the IP address 192.168.10.2, for example. Here I can see, because there's a reply, that it's up. What about 3? Same situation. Now I know that my IP ends in 4, so let's test 5. Okay, I can see that that's not an IP within my range. So now I know which IPs I need to focus on, the .2, the .3. Now, it would be really good for me to know what type of devices they are. So let's run this command, arp-a. Now this is going to give me the internet address and then the corresponding physical address. So I have now this information which is going to help me gain access into a machine that I really should not have access to. Now, outside of this environment, this simulation environment, another command I could use to see which ports are open on the machine would be nmap. This will enable me to see if there's any weak ports that I could infiltrate. Now, I really want data from the engineering team. So I need to do the same for a port for the engineering VLAN. And as we know, John has done a really good job about securing the VLAN. And I actually can't find a port which is open and configured for engineering. So unfortunately, what I'm going to have to do is unplug an already connected device and replace it with my device. And this is not good for me, as I'm going to disturb someone else's traffic and they will know that something's going on. So I'm going to have to work fast. As we know, John the architect is very good at securing his network and engineering. We can see in the interface Linda was connected to that there is port security. The violation mode is restrict, which means it will block the traffic if it is a different MAC address to Linda's. Before I, the attacker, try to infiltrate the network, John run the following command, which shows the port security settings. It shows it to be enabled, it shows the port to be up, the violation mode to be restrict, and the last source address to be Linda's MAC address. Now I, the attacker, has plugged my PC into Linda's port, I actually can't get an IP within that VLAN, the engineering VLAN, configured dynamically on my machine, like I could when I was connected to the marketing VLAN. So let's see what's happening in the switch. John has logged into the switch again and done the same command. Show port security interface and the interface of Linda's port. This was where once Linda's PC was connected. Now we can see that the security violation count is 25. This is how much times the port has been violated. And as we know, the attacker was not able to have an IP to be part of the engineering network. So let's go deeper on what John has done to protect his network. He has put in configuration on the ports that when devices plugged in do not have the same MAC address of the device which was originally connected to it, it will not only restrict the traffic, however it will log an event, log the MAC address from the machine of the hacker, and also can be linked to raise an alert to the security engineers. This is terrible news for me, the hacker, and also as John is a fantastic security architect, he has prompted that all the MAC addresses of all the employees' devices is stored within a database. This means not only does the engineer know that someone is doing something bad within the company, however, now they know it's me. Because of John's actions, not only was the engineering data safe, however, myself, the hacker, was removed from the company with legal actions. This really should give you a good insight on the protection of physical assets as well as the layer 1 of the OSI model. In our next lesson, we will talk about the layer 2 of the OSI model, which is the data link layer. Take a break, refresh, and I'll see you in the next lesson.